Java as a language and as a platform has an amazing history of over 2.5 decades. And by 2025, it will complete its third decade. The reason for its continuing relevance and productivity lies in the fact that the language has continuously evolved itself to meet the pace of change in the industry, be it developers' new productivity related needs or requirements of the new hardware and architectural practices. Due to its long history, now there are multiple ways to not just develop Java application, but to deploy those applications into production too. So what are these different deployment options? Let's take a look. If we start chronologically, it all started with jars, the Java archive files, which contain library code or a runnable artifact. The initial best practice to deploying Java Enterprise Edition applications was to package the code into a series of jars, which includes the modules with Enterprise Java beans, EJB class files, and EJB deployment descriptors. And these were further bundled up into another specific type of jar with a defined directory and structure and required metadata file. And that bundle was used to be either a web application archive WAR, which consisted of servlet class files, JSP files, and supporting files, or an enterprise application archive EAR, the mix of jar and WAR files in the deployment of a full J2E application. Those artifacts were then deployed into either some heavyweight application servers like WebLogic, WebSphere, or JBoss EAP, or into some lightweight application servers launched later like Apache Tomcat, Apache Tommy, and Red Hat's Wildfly or Payara server like that start and deploy in a few seconds. Because due to their internal comprehensive modularity, they are able to load only needed components and deploy the thin application artifacts as quickly as possible. Then came the era of what we call the executable FET jars and the rise of 12 factor F methodology. With the introduction of cloud friendly service based architectures and the open source and commercial platform as a service platforms, the past platforms like Google App Engine and Google and Cloud Foundry, as we have discussed, we started to deploying Java applications by using the lightweight and embedded application servers. And further with application frameworks like Spring Boot and through mechanisms like Maven and Gradle, we started to package and embed these application servers into a single deployable unit that can run as a standalone process. And the idea of executable fat jars came into practice. Some of the best practices for developing, deploying, and operating this new generation of applications are codified by the team Heroku as the 12 factor app methodology. We have already discussed that in the previous video. With that, now the deployment choice is moving toward the containers. Now we talk about the container images. So if fat jars extended the scope of traditional Java packaging and deployment mechanisms, containers have taken this to the next level. Now, in addition to packaging your Java application as a fat jar, you must include an operating system within your container image. Because of the complexity and dynamic nature of running containers at scale, now we use container orchestration and scheduling platforms like Kubernetes, Docker Swarm, or Amazon ECS. And from 2014, we have started talking about the function as a service or the idea of serverless. Whether it's AWS Lambda, which was launched in November 2014, or Azure Functions and Google Cloud Functions that launched as a response to that in 2016, what all these platforms do? They let the developers to run code without provisioning or managing servers. That's why we call this approach as serverless or function as a service. With function as a service, servers are still required to run the functions that make up an application, but the focus is typically on reducing the operational burden of running and maintaining the functions underlying runtime and infrastructure. And the development and billing model is also unique in that functions are triggered by external events, and you pay for only the time your functions runs and the memory consumed. Both AWS Lambda and Azure Functions offer support for Java, and with that, we can say we have now returned back to the deployment requirement for a jar or zip file containing Java code to be uploaded to the corresponding service. In the majority of cloud and microservice deployments, standalone jar packages are used. These contain both the application and the runtime implementation. So, this is how the Java deployment platforms have evolved over the years, and this is where we reached now. Now the question comes, how does these changes in deployment platforms affect the developers and how they impact the continuous delivery? Well, we can say that packaging format clearly has an impact on the way an application or artifact is built, tested, and executed. But the core concepts, principles, and assertions of continuously delivering a valid artifact remain unchanged.